Good afternoon, everybody. I'm excited to be here at PyGotham 2018. Today I'm going to talk to you about how to write better software tests. There's so much I could say on this topic, so my half hour is going to be limited primarily to high-level points. I will be sharing some code, but overall it's going to be mostly practices rather than code implementation. To give a little bit of introduction about myself, my name is Andy Knight, also known as the Automation Panda. I am a software engineer in test. I have a lot of experience with testing, automation, and behavior-driven development. I live in Raleigh, North Carolina. I went to Rochester Institute of Technology, and I'm an avid Pythoneer. You can follow me on Twitter at automationpanda.com. I've already pinned to my profile a tweet that has a bunch of resources that will parallel today's discussion. So if you're on Twitter, please check those out. You can also read my blog at automationpanda.com. This is a lovely picture of me from PyCon 2018. Woo-hoo! I'd also like to thank my company, Precision Lender, for sending me here to sponsor me to give this talk. At Precision Lender, we make a pricing, profitability, and most importantly, a sales enablement tool that uses artificial intelligence to provide insights and coaching to commercial bankers as they make deals. So here's an icebreaker question for us. Raise your hand if you have ever hit a software bug. Yeah, I think just about everybody's hand is up, right? Maybe you discovered it. Maybe you even caused it. Bum, bum, bum. Right? So now let's ask another question. Raise your hand if you always test your code. Not as many people. OK, no worries. There's no shame here. This is a Python conference. So here's a third question. Why don't we automate those tests, right? We all said we all hit bugs, so we've kind of admitted that we need to do software testing. Some of us raise our hands, yeah, we do testing, but I'm guessing a lot of those hands were doing manual quick checks or maybe some debugging, maybe not like real automated tests. So let's have some real talk about this. We know test automation as a necessity for modern software development. Things move fast. For example, I know Facebook uses a push from master scheme to push their code changes out in continuous integration. With that example, you see that you don't have time to manually test everything, right? There's just not enough time in the universe to test everything, let alone do it manually. So you really, really need an automated solution that you can push a button or upon a code commit, everything gets tested automatically. But even though we know that's necessary, we must also admit that test automation is hard. This is my day job, and I admit it's hard. You need strong development skills in order to do test automation because it is a software product. It's not just writing test scripts. There's a whole stack involved, a whole bunch of frameworks, a whole bunch of tools. And there's a lot that goes into building a test automation system. And not only that, but when your product under test is constantly changing, your test automation has to keep up with it, or else it's going to be testing the wrong things and possibly crashing. Third, we must also admit that test automation can be intimidating. The typical developer isn't as familiar with testing and automation practices and skills and tools. And so there can be this learning curve. Or it could be that you have a QA team of historically manual testers that just aren't as good at development as, say, developers are. They have skills in different areas. And so what I see a lot of times, just talking to different companies, big and small, is one of two situations. Either they know they need to do testing and automation, and they haven't done it yet, and they're hitting this critical point of we've pushed too many features, too much code that's untested, and now we're in trouble, oh crap, and we don't know where to begin, we're paralyzed. Or you have companies that have tried something, they've written hundreds to thousands of tests, and they're really bad tests. They don't test the right things, they're flaky, they crash and burn, their pass rates are horrible, and so they've spent all this time and effort and essentially failed at the test automation challenge. And so that, either way, it leads to this moment. Egad, I need better tests, or I need good tests to start with. What do I do? Why is this so hard? Where do I get started? Egad. It's OK. You're not alone. Let's meet somebody who can help us. I'd like you to meet Amanda the Panda. Amanda is a software engineer who loves using Python. Amanda works at Bamboozle, a small but growing tech company. Bamboozle provides an online platform for Panda e-commerce. As a full-stack developer, Amanda has a good understanding of Bamboozle's web front-end, REST API service layer, and infrastructure needs. Recently, Bamboozle had a couple severe bugs escape into production. Ooh. Egad. Management decided it was finally time to start automating tests, and Amanda volunteered to lead the effort. Go, Amanda, go. Since this is the first time she's done test automation, Amanda does her homework. She starts learning about different testing types, tools, and frameworks. However, her web research feels more like a game of buzzword bingo. There are so many catchphrases out there, and people seem to give different definitions for different terms and phrases. What are the differences between integration, end-to-end, functional, regression tests? Why are there so many different frameworks? Do I really need packages like Selenium WebDriver and Cucumber? Egad, what do I do? So, Amanda calls her friend Andy, who's a software engineer in test. That's me. That's a cucumber on his head. 10 points if you can figure out why. There's so much information out there, Amanda says. I can't discern what is the right approach to take. Let me ask you a question, Andy asks. What is your main goal with testing? Well, Amanda replies, I guess I want to make sure that all critical parts of the Bamboozle app are working correctly. Anytime someone introduces a bug, tests should catch it immediately. Great. It sounds like you need a functional test automation solution. Functional tests make sure that features work correctly. As you said, functional tests serve two main purposes, validating goodness and identifying badness. I'd like to show you the test automation pyramid to help put some pieces together. The pyramid is a rough guideline for how an automation solution should be structured. All layers are functional tests. At the bottom are unit tests, which cover individual pieces of code, like functions, methods, and classes. Unit tests are white box, quote unquote, because they have direct access to the code under test. They test code. Above that are feature tests, which cover black box behaviors of real live instances of the product under test. Integration tests cover where components meet, typically at the service layer. End-to-end tests cover paths through a system, such as testing through the web UI would do. Each layer of the pyramid mitigates risk at its optimal return on investment. We want a strong foundation of unit tests because they are small, quick, and easy to maintain, and they are also close to the code. Integration and especially end-to-end tests are far more costly to maintain, and they also take much more time to run. Consider the rule of ones. Unit tests typically take 1 millisecond, whereas integration tests typically take 1 second, and end-to-end web tests can usually take up to 1 minute. Hold on, Amanda interjects. Why do we even need feature tests? They sound like such a burden when compared to unit tests. I also read that web tests can be really flaky. Andy replies, well, unit tests don't catch every single issue. Here's an example. Back in 1999, NASA lost the Mars Climate Orbiter when it disintegrated into the Martian atmosphere. Why? Ground-based software did not convert US measurements into the metric system. Ooh. The calculation modules worked individually, but they did not integrate properly. Had NASA checked the software with proper integration tests, they would not have lost $655 million. Wow, Amanda exclaims. I wouldn't want that to happen at Bamboozle. It sounds like I need to take a pyramid approach. So what skills do I need to get started? Andy smiles. Good news. You already have the skills. Test automation is software, and the same development principles apply. Just pick a core framework and get rolling. You may also want to take some online courses about the frameworks and test packages you need. So there's another question, Amanda asks. What test framework should we use? Bamboozle uses a lot of Python on the back end, so I looked into frameworks like Unit-test, PyTest, and Behave. Python is one of the best languages for automation, Andy replies. And you can't go wrong with PyTest. PyTest can handle tests at all layers of the pyramid. Markers can categorize tests, test functions and fixtures are lightweight, and plugins can add support for reports, code coverage, and even parallel execution. Among all Python test frameworks, PyTest is also arguably the most Pythonic. A test automation solution is more than just its core framework, however. Successful automation projects bring together readily available packages rather than developing everything from scratch. Python's standard logging library is a must. Requests is great for testing REST APIs, and Selenium WebDriver is the mainstay for web browser interactions. Python also has integrations with popular frameworks like Flask and Django. Use what makes sense for your tests. I can also recommend a few books to help you get started. Python Testing with PyTest by Brian Ocken and PyTest Quick Start Guide by Bruno Oliveira are both excellent resources for learning how to use the PyTest framework. Hands-on Python or hands-on enterprise automation with Python by Bassem Ali is helpful if you want to learn network, system, and administration tricks to bolster your test automation work. Great advice, Andy, Amanda says. This will help me get started. So, Amanda goes back to Bamboozle and starts writing tests in Python using PyTest. She found it was fairly easy to get started. Taking a pyramid approach, she starts beefing up existing unit tests and then moves on to using requests for REST API testing and Selenium WebDriver for web UI testing. She puts the test code in the same repositories as the product code so that they are version controlled together. However, after writing a number of tests, Amanda discovers some frustrations. She meets up with Andy for bubble tea to pick his mind. Andy, she says, how do I avoid duplicating so much test code? So many of these test steps are the same, just with minor tweaks. Code duplication is code cancer, Andy replies. Code duplication is code cancer. Have you heard about property testing with Hypothesis? It could help you get started with unit testing. Hypothesis automatically runs tests against a wide range of scenarios that you don't need to hard code. Also, to avoid duplication with feature tests, try using Gherkin with the pytest-bdd plugin. You can write test scenarios in plain language using given, when, then scenarios, very similar to arrange, act, assert. And each step is glued to Python functions to help execute those steps. Steps can be reused by different scenarios as well. Gherkin also helps you focus on the intended behavior for the test to cover rather than getting lost in implementation details. Try using the screenplay pattern to model your web and service interactions too. I'll definitely check out Hypothesis and pytest-bdd, Amanda exclaims. I think there were talks about them at PyCon 2018. Now, here's another question. Have you handled test data in the past? My unit tests use PyTest's monkey patch feature to mock data. But I'm struggling to find good ways to manage data in the Bamboozle systems for black box testing. Test data is definitely hard to maintain, Andy replies. Try to keep test data to a minimum. For most tests, data needs are small. Tests should set up and clean up whatever they need, such as database records or custom settings. Some data, like user accounts, however, are expensive to prepare and should be handled outside of the test automation. For that, it's usually best to write scripts to prepare the system before the test suite runs, and then to periodically clean up and regenerate that data, just in case the tests unexpectedly do some damage. That makes sense, Amanda says. I've also been storing inputs like URLs and usernames in local config files, so they aren't hard-coded into the test code. Awesome, Andy replies. That's great. You may also want to consider using some sort of secret key service like Amazon's or AWS KMS or Azure Key Vault. That way, your passwords will be secure and your config files won't go stale. Amanda goes back to Bamboozle and uses what she learned to improve her test automation project. It becomes her full-time work, and she transitions unit test work to the developers so she can focus exclusively on feature-level testing. She does so well that her team keeps asking for more and more tests. Despite training other developers to help write tests, she becomes buried by her testing backlog. Amanda takes a step back and asks herself, what tests should we automate? Her answer is simple. Automation is expensive, so focus on return on investment. She writes guidelines for her team to avoid getting crushed by an impractical 100% automation goal. She recommends automating happy paths of core features that will be run repeatedly. She also recommends avoiding edge cases, one-off checks, and visuals because those would be much easier for an expert to check manually. Amanda also recognizes that these are simply guidelines for her team and may not apply universally for everyone. Even after narrowing the scope of tests to automate, the number of tests left in the backlog is still quite large. Amanda's team has hundreds of feature tests that will balloon to thousands in the coming year. The service level tests take about 10 minutes to run, but the web tests take over an hour. It's no longer practical for developers to run them for every single code change on their local machine. So, Amanda calls a meeting with Otto the Panda, a developer at Bamboozle, and asks, how can we reduce the burden of test automation so that developers can be more efficient and effective? It would be really nice if we could run these tests as part of a continuous integration and delivery pipeline, Otto says. Then, every code change I make as a developer would be automatically tested. The only problem is that the tests still take a long time to run. What if we run the tests in parallel? Amanda asks. We could use the pytest-bdd plugin. It could plug in directly into our existing PyTest framework. Parallel testing would be hard on our laptops, but easy to scale in a continuous integration environment. Just add more VMs. I can make sure that the test code is thread safe and would have no collisions like web logins. Thankfully, PyTest fixtures can help us set up and tear down everything cleanly and safely too. If necessary, we could set up Selenium Grid to scale out test execution across multiple nodes and also for cross-browser testing. Or we could use a platform as a service like Sauce Labs or Browser Stack. That would be awesome, Otto replies. We also need to make sure feature owners are automatically notified of test failures. That way, they can triage the failures immediately. Amanda and Otto team up to make this happen. Amanda updates the automation code to use pytest-bdd, and Otto adds new jobs to their existing Jenkins build server for running test suites. They also set up a report portal I/O instance to be their test result dashboard. Tests complete in a fraction of the time, and developers get failure notifications immediately. However, adopting true CI brings unforeseen consequences. More test runs means more issues uncovered. While most tests run fine, some start failing intermittently. 4 common failure reasons are, number 1, the feature under test has a tricky bug. Number 2, the feature under test was updated without also updating the test. Number 3, the automation didn't handle an unexpected condition. Or number 4, bum, 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 the automation itself has a bug. Unfortunately, the failures leave a bad impression on the team. Some of Amanda's team members stop triaging test failures and even suggest skipping tests. Right? It happens. Amanda doubles down. How can we make tests more reliable, she asks herself. First, she realizes that CI is the production environment for tests and should be treated as such. Tests should undergo the same best practices as product code, including coding standards and reviews. Shared test framework components should also have unit tests. Second, she discovers that most common points of failure are remote calls and race conditions. She tunes the framework to have appropriate timeouts, immediate retries, and helpful messages when problems arise. She makes it correct what it can and safely abort when it can't. She also investigates using contract testing for service testing to be a little bit more safe. Third, she reaches out to her team members for better collaboration. They institute better processes for flagging feature changes that will affect tests and for being gracious on both sides when failures happen. As a result of these 3 things, automation becomes more reliable and confidence in the test is restored. By this point, the automation solution has matured. New tests are being added every sprint, and results provide feedback to development immediately. There's tons of work to be done, so Amanda's manager is looking to hire more software engineers and test. He asks Amanda, what should we look for hiring SETs? That depends upon our needs, Amanda says. The word test and QA in someone's title can be misleading. Some people are good at manual tests, some people are good at test automation, and some people are good at setting up the solutions. We should carefully consider what we need before we go looking for candidates. And that is all I have to say about Amanda's journey. There's way more than I could say in 20 to 25 minutes here. So I've posted some resources for everybody to go learn some more. My blog, Automation Panda, has a number of articles on testing, automation, and Python. Also, here are the books that I've recommended for learning about Python or automation with Python. And here at the bottom, I've put a list of all the different tools and packages and modules mentioned in this talk. If you have any questions, do we have time for them now? I can take some questions now. If not, I'll be around. You can tweet at me. I've also listed all the resources on Twitter, so feel free to come ask.
How does bdd or cucumber test help reduce code duplication?
Because you can reuse the steps. You write a step once, it can be reused by multiple scenarios. A lot of times what you find with more traditional test frameworks, a la just writing a function or a method, a lot of people who are less disciplined will typically copy and paste similar calls over and over again. The BDD framework structure, the Gherkin-based BDD frameworks kind of help you to more easily reuse steps instead of just copy pasting code. You could arguably make good modules to do the similar kinds of things, but that's one way to help. Yeah. BDD frameworks also force things to be more descriptive as well, separating your test cases from your test code. Any other questions? Yes? On their page, Nose recommends to use PyTest because I believe Nose is deprecated. Why PyTest over unit test? In my opinion, unit test is a bit clunky and basic. PyTest is leaner and cleaner and has more features and more extensibility. I prefer to write test functions instead of test classes because there's less of a chance of side effects and a whole bunch of other reasons we can talk about a little bit later. Yes?
Can you comment on Jenkins versus build kite, circle, Travis, any of those CI solutions?
I can comment. I don't have much to comment on. I chose Jenkins in this presentation because A, I'm most familiar with it, and B, it's open source. That was all. You can use it with any of the other guys. Yes?
Can you recommend any libraries for test data, like generating test data for you on the fly, things like that?
I don't know any offhand, but I would love if anybody can recommend them.
Can't you just, you can add your own stuff to hypothesis to make test data for you, depending on what kind of test data you know, right?
That's cool. I'm not sure.
I know you can add your own strategies to hypothesis.
Cool. Well, there you go. Cool.
There is a Python library called fuzzing I've used in the past that is great for generating test data based on strategies.
Cool.
Just fuzzing.
Nice. I hope that helps.
Thank you.
What does report portal do you use that? Jenkins out of Python? What does report portal do?
Report Portal has a bit of a nicer UI. You can mark certain tests as being owned by certain people so they get automatic notifications. It also has some niftier algorithmic features, I believe, that will look at commonly failing tests and kind of flag those to say, hey, this has failed in the past. You should look into this particular one. Yep. Was there another? Yes.
I was just one of the like you're in a bad place examples that you gave earlier was tests that you have trouble getting past.
Yes.
Like polls, tests. What kind of just wondering if you can like give us some of the stages of grief that you might go through deciding whether you just like how do you decide when you can just delete the test?
Can we talk about that offline because that would be a blah 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 blah.
That's all the questions we could take.
I'll stand out in the hallway for more.
If you want to ask more questions, it seems like they'll be available.
Great. Thanks, everybody.